Hello and welcome back to Make Games using Odin programming language and Raylib. In this second episode we will add a player character, then we will make it possible to move this player character around, and then finally we make it possible to jump and fall. Just like the first episode, this second episode also has a companion blog post. You find the link to the companion blog post in the description of this video. It says pretty much the same stuff as the video, but in text format. On the right side here, we have an outline of what we will be doing today, but essentially, like I said, we will be adding a player character and then make it possible to move it and then make it possible to jump around. I have the code from where we left off last time over here, and I can run it again just to show you where we left off. We essentially just had a tiny Odin program that creates a window and then makes a game loop where it constantly clears the background with a blue color, and then if you click the close button, it closes the window. Okay, so let's jump into the first item here, add a player character. Initially for our player character we will use a green rectangle, but in later episodes of this series we will replace it with an animated sprite. So in order to draw a green rectangle using Raylib, you make a new line after the clear background. The stuff after clear background but before end drawing will end up in front of the background. So we write rl.drawRectangleV. And then we need to specify where on the screen do you want to draw your rectangle. And I will say that we want to draw it at 640, 320. And this is roughly in the middle of the screen because our screen is 1280 by 720 big. And then we need to specify how big should the rectangle be, and I want it to be 64 pixels wide and 64 pixels high. And then we finally need to specify a color, and I will, just like we can write rl.blue, we can write rl.green. And if we now press F7, remember in the end of the previous video I showed how to set up the build system, so you can build from within Visual Studio, which you do by pressing F7 if you set all that up. If you compile this and run it, then you see that you have a green rectangle in the middle. So this 640 here specifies how many pixels from the left should it end up at, and the 320 specifies how many pixels from the top should it end up, and the position it's looking for is actually the top left corner of the rectangle. Now you might ask, how did I know that this drawRectangleV proc exists in Raylib, and how did I know that it takes these parameters in this specific order, etc. Well, I can show you how I figured that out. If you open the file browser in Windows, or the Finder on Mac, and whatever it's called on Linux, and you go to your C drive, and then you find where you put Odin. Here is my Odin folder, C Odin, and then inside the Odin folder there's a couple of different folders. The vendor folder, you might recognize the word vendor from your import statement here. This is where all the different libraries that Odin ship with come. In here you find stuff like OpenGL, Vulkan and stuff, and also you find Raylib. So if you open the Raylib folder, then you have a few files in here. If you take raylib.odin and you drag and drop it into Sublime, and then you can press escape to close the console at the bottom. And then you scroll down, you see there's lots of stuff in here, but we can search for drawRectangleV. So this is the drawRectangleV, and then it says here that drawRectangleV is a proc that wants a position, a size, and a color. The position, this is the name of the parameter, and this is what's called the type. In this case the type is a vector2. So what is vector2? It's essentially just two decimal numbers that you can use to specify position, sizes, and directions, etc. So both position and size are vector2, and then the color is a Raylib color. So if we go back to our game file now and look here, so this is what's going into that position parameter, and this is going into the size parameter. And the color, we've currently used rl.green, but you can actually make your own colors. And the way you do that is by, instead of green, you can type, for example, 255, 180, 0, 255. And then if you recompile now, it should become sort of orange instead. And the reason it is orange is because this first number here is how red should it be, the second number is how green it should be, and the last number is how blue it should be. And this last one is the alpha, which specifies how transparent it should be. Now, these numbers go between 0 and 255. So this is maximum red, and this is sort of slightly more than halfway green, and there is no blue at all in this. So you can mix your own colors like this. But I will press Ctrl Z and go back to having it green for now. So now that we have the player character drawing in the game, we can go ahead with the second point, make the player character movable. Like I said, this 640 by 320 thing here is the position at which we are constantly drawing the player. And by constantly drawing, I mean that these 4 lines here are happening in a loop. This loop is running as fast as your computer can. Maybe it's running at 60 frames per second, maybe 2000. There is no frame rate limiter in this game yet, so I don't really know. So in order to change this thing, in order to vary it, we're gonna turn it into a variable. And the way you do that is outside the loop, but after init window, you can write a new line, and you write player pos, and then you write colon equals rl.vector2, and then you can write 640 by 320, the same number as here. And then we can go down here, and we can use the value of player pos by just writing player pos. So now this will, if we run it, it will still do the exact same thing, but instead of the value being written here, it reads it out of player pos. And what we can do now is that we can, each frame, we can check for key presses and change player pos, which will move the player character. So let's do that. So to start with, we can check if the left or right arrow keys on the keyboard are being held, and in that case move the player character's position. So just before drawing the player character, like this, we will write if rl.isKeyDown, and then we write dot, and then in all capitals left. And then we make the little curly braces again, and we make a new line. And this is called an if statement, and an if statement says that if the condition here is true, then please do the stuff between this curly brace and this curly brace. So in this case, left arrow key is held, then we want to move the player's position to the left. So we do that by writing player pos.x. X means the first one. This one is usually you can get with Y, and this one you get with X. And we want to decrease that one. We want to move it to the left on the screen. So we write minus equals 400 times rl.getFrameTime. Now, my intention here is that I want the player character to move at 400 pixels per second. And since, like I said, this loop here, the for loop here, might be running at any kind of frame rate. So I don't know how fast it runs. So in order to make this run at a steady 400 pixels per second, if the key is being held, then I also multiply by getFrameTime. rl.getFrameTime tells me how many seconds did the previous frame take. Now, rl.getFrameTime is probably a very tiny number. It is a decimal number in seconds. You don't need to write this. This is just me writing a comment here to write how small this number is. It's probably something like this. But if your game is running at, thousands of frames per second, it might be something like this. That small, these few seconds. So each loop of this frame, while the key is being held, it's just gonna take a tiny bit of 400 and move you to the left with that. And if this still doesn't make any sense, why this would make it so that it moves at 400 pixels per second, then think maybe if your game had terrible frame rate. Let's assume that it runs at 2 frames per second. 2 frames per second means that rl.getFrameTime would tell us 0.5 second. Because then you get 2 frames per second. And if you multiply 0.5 with 400, then you get 200. So after 2 frames then, you will have a total of 400 pixels. So then we need to do roughly the same thing for the right arrow key. We write if rl.isKey down, and then we write dot right. And then we write player pos dot x plus equals instead of minus equals 400 times rl.get frame time. If we now press the F7 button to compile and run, and we use the left and right arrow keys, we see that we can move the player around. You might ask, this minus equal and plus equals, what does that really do? It's just a short way of writing this. So it takes the player position.x and it subtracts this thing from it and then stores it in player position.x again. So it's just a shorter way of writing that. And like I said, the .x changes this thing, and .y, which we haven't used yet, but we will use that when we jump, changes this part. If you're interested in which additional keys you can check for in Raylib, because this checks for the left arrow key and this checks for the right arrow key, then you can go back to the raylib.odin file we opened before, and you can search for keyboard key. And here is all the different things that you could write here. So you can check for the A, B key, blah, blah, blah. Yeah, here is right and left keys. So you can experiment with that if you want to. So now that we have made it possible to move the player to the left and to the right on the screen, we want to make it possible to jump and fall. And the way you can do that is by adding it so that when you press a key, or jump key, the player gets an upwards velocity, and then gravity pulls the player down again. And velocity is just, the sort of the concept of speed combined with a direction. So like how fast am I going, but also in what direction. And since that means you need to know like, okay, essentially how fast am I going in both the X and Y direction, it's good to use again a vector too. So just below the player pos line, we write player vel. Vel is short for velocity. And now we write colon rl.vector2. And you can look here at the, here it's just a colon, here is a colon equals. And this is how you create a new variable, but you don't specify how, like what the initial value of it is, because up here we needed to say what initial value will it have. However, in Odin, whenever you don't specify the initial value, it always gets 0 as initial value. So this is the same as writing this. But we don't need to do that. Everything gets 0 initialized, we say in Odin. So now that we have a player velocity up here, we can use it in the main loop down here. So what I will do is I will change this line here so that instead of altering the player position directly, it says when the left key is held, it says player vel.x equals -400. So as long as you're holding the left arrow key, the player vel.x equals -400. And then I'm gonna put my cursor on this line and I'm gonna press the delete key a few times so this code comes up, and I'm gonna add in the word else here. And what this does is if this condition here is true, then it will run this code. But if this was not true, so it never actually ran this, then it will check this condition here and run this code. And we'll replace this code with player vel.x equals 400. So then it goes to the right. Minus is to the left, plus is to the right on the x-axis. And then finally we will add a third thing here, which is just an else, where we will write player vel.x equals 0. So if the left arrow key is held, make the velocity.x -400. If left arrow key was not held, but actually the right arrow key is held, then you put the x velocity to 400. But if none of them are held, which this means, since it has already checked left and then right, if none of them is held, then just 0 the velocity. Currently we are not using this velocity, so that's the last thing we need to do here. We write player pos plus equals player vel times rl.get frame time, like that. And if we run the game now, then nothing has changed again. This is a recurring thing, but we have changed the code now so that we have a velocity which we can use to jump and also apply some gravity. I just want to make a note about this line here as well, because previously we changed, you know, the player pos.x. We just changed one number. What we're doing here is we're actually changing two numbers at once. We are changing the player pos x and y at the same time by just adding the whole velocity times the frame time. And you can do this in Odin as long as this player pos and player vel has the same number of things inside them. Both are vector 2s, which means two numbers. Then you can do these kind of things. So in order to simulate gravity, we will add a line just after all this if stuff here that says player vel.y plus equals 2000 times rl.get frame time. This 2000 is sort of my gravitational acceleration, and we multiply it by the frame time because we want the same amount of acceleration downwards to be applied per second. And now we need to make it possible to jump. So we write, just after this line, we write if rl.is key pressed dot space. We will use a space bar to jump. And again, this is what the code in here will be executed when space is pressed. And then we just say player vel.y equals -600. So you will constantly be pulled down by gravity, but whenever you press spacebar, your whole velocity will just be replaced by -600, which is a fairly fast upwards velocity. Remember, the Raylib counts from the upper left corner of the window, and then positive x goes to the side and positive y goes downwards. If we run this game now, something quite silly will happen. Do you see it? Run it again. The player just falls and disappears. This is because there's no floor in our world. And we will add this floor in a fairly simple way by just after you change the player position here, we write if player pos.y is bigger than, and now I'm gonna write something here which I will explain in 2 seconds. I write f32 rl.get screen height -64. So what this thing here says is that if the player's position is bigger than the screen height, remember the screen height we said was 720, but the reason I'm using get screen height here instead of writing 720 is maybe the game has changed resolution since we started it, so it's better to do like this. And then I write -64 here. And if this is true, then the code in here will be run. And in that case, we will write player pos.y equals f32 rl. We write the exact same thing, -64. Now, in order to explain exactly why this is like it is, I can bring up my blog post here. There's a little picture in there that I made. This one. So, like I said before, the little green rectangle for the player, the position is actually the upper left corner, and then it's 64 pixels high. And the screen height is 720, like this. And if we subtract 64 from the screen height, then we get the position at which the player, if the player has a bigger position than this number, then the bottom of the player is actually sticking out at the bottom of the window, which is what we're trying to avoid. We're trying to make the sort of bottom of the window into the floor which you can stand on. So that's why we're subtracting 64 from here, because that's the height of the player. And if we now run the game, then you see that the player fell down and stands there, and we can move left and right, and then we can press space to jump. But now, if you play this game for more than 2 seconds, you will try to jump in the air, and then you notice that you can jump constantly while in the air. And since we're trying to make some kind of platforming game or something, some kind of little 2D game with platforming mechanics, this is not so good. Maybe if you're making Flappy Bird or something, this will be good, but not for us. So we're gonna fix that. Which brings us to our 4th point, disallow jumping while in air. Now there's a couple of different ways to fix this. How we are going to do it is that we are going to add a variable that says if you are standing on the ground or not. So I'm going to go up here again, just under player vel, I will write player grounded, and I write bool. Bool is a special type in Odin that can only have the value false or true. And just like this thing up here is initialized to all zeros when you don't specify something, this one is auto-initialized to the value false. So now we can use this player grounded variable down in our code. So in this if is key pressed space thingy here, we will say player grounded equals false, because when you jump, you are no longer on the ground. But we also want to make it so that you can only jump when you are on the ground. And to do that, just before the is key pressed stuff here, we write player grounded and we write like that. So what's this stuff, you might ask? This is called the AND operator, and what it does is that it checks if this thing is true and this thing is true. But now you might ask, but okay, this thing here is a bool, it can be true or false. But this thing here is, here I am calling a proc in Raylib that checks if space is pressed or not. How can that be of type bool? Well, these procedures we've been using here, is key pressed, window should close, is key down, are all procedures that return the value bool. We can look in raylib.odin again at is key pressed. And if you look at this line here, this is a proc that takes one keyboard key. In this case, maybe we check for spacebar or left or right or whatever. And then the little arrow with the bool here is what stuff this is key pressed will return. So you can use whatever this proc returns, just like the player grounded variable, because both are of the same type, bool. So this and thing here checks if this is true and this is true, then we'll run this. If any of them is false, if you're not pressing space or if the player is not on the ground, then this code will never run. So now we just need to do one more thing. When you hit the floor at the bottom of the screen in here, then we write player grounded equals true. You hit the ground, therefore you are on the ground. So now, if we now press F7 to compile and run, now we see that our cube is standing on the ground, but if I press space while in the air, nothing happens. So now there we have it. We now have a player character that we can move left to right, we can jump, and we can only jump while on solid ground. So that's it for today. Thank you so much for watching. If you have any questions, then just leave a comment. I will try to answer some in text and some I will save for a Q&A live stream session. In the next episode, we will add it so that the player has a little sprite animation instead of being just a green cube. If you enjoy these videos and you want to support me, then you can do so by buying my game Cat and Onion on itch or wishlisting it on Steam. The game is completely made in Odin and Raylib, and if you buy it on itch, you even get the whole source code for educational purposes. Thanks again for watching. I will see you next time. Bye!